Signal number 1 on this list came from a small radio dish in Ohio on August 15, 1977, and it lasted exactly 72 seconds. An astronomer named Jerry Ehman saw it printed on paper, circled it in red pen, and wrote a single word beside it. Wow! That word became the name of the most famous unexplained radio signal ever recorded from deep space. It came from the direction of Sagittarius. It matched almost exactly the frequency scientists predict an alien transmission would use, and it has never repeated. Not once in over 45 years of searching. But what's even crazier is that this was not even the first strange signal to ever come from the sky. It was not the strangest. It was not the most dangerous. It was simply the first to make headlines. Signal 1 on this countdown is that wow signal, and it remains completely unexplained to this day. No repeat, no source, no confirmed origin. Scientists have proposed comets, hydrogen clouds, even a passing satellite, and none of the explanations fit perfectly. Somewhere in that direction, 1,800 light-years away, something sent a burst of radio energy directly at Earth, or Earth simply happened to be in the path of something far stranger. But that single anomaly is nothing compared to what astronomers found a decade earlier, ticking through space like a heartbeat. Before the WOW signal ever reached Earth, a graduate student named Jocelyn Bell Burnell was staring at pen traces on a rolling strip of paper in 1967, and she noticed something impossible. A signal, pulsing every 1.33 seconds with the regularity of a clock. It was so precise, so mechanical, that her team nicknamed it LGM-1, Little Green Men. For weeks, they genuinely considered the possibility they had found a beacon built by another civilization. Signal 2 on this list turned out to be something almost as strange as an alien beacon. A dead star, spinning hundreds of times per second, sweeping a beam of radiation across the galaxy like a cosmic lighthouse. We call these objects pulsars now, and there are thousands of them mapped across the sky. But here is the unsettling part. If a pulsar's beam sweeps across Earth even once, and then the star shifts its rotation just slightly, that beacon disappears forever. And we would never know it had been there at all. That is a signal we understand. The next one, we do not. In 2007, astronomers sifting through old radio data found something lasting just milliseconds. A flash of energy so brief and so powerful it seemed impossible. Signal 3 on this countdown are called fast radio bursts, and in that fraction of a second, some of them release more energy than our sun produces in an entire year. Thousands of these bursts have now been detected, flashing from galaxies billions of light-years away, and for most of them, we still cannot identify a source. And this is where things become strange. One particular burst, catalogued as FRB 121102, does something none of the others do. It repeats. That repeating signal, FRB 121102, sits at signal 4, and it has fired off bursts hundreds of times since it was first identified, from a dwarf galaxy 3 billion light-years from Earth. Whatever is producing it survives the event over and over, which rules out most catastrophic explanations. The leading theory points to a magnetar, a dead star with a magnetic field trillions of times stronger than Earth's, capable of warping atoms from a distance. But no model fully explains the pattern of its bursts, and some patterns in the data still defy every explanation offered. So what happens if the signal is not natural at all? Nobody can rule that out, and nobody can prove it either. Take a signal like that and strip away everything except pure noise, and you get something even older. Signal 5 on this list is not a message. It is a leftover glow filling every corner of the universe. Discovered by accident in 1965 by two engineers testing a radio antenna in New Jersey, who could not get rid of a strange hum no matter where they pointed their equipment. That hum turned out to be the afterglow of the Big Bang itself, the cosmic microwave background, radiation that has been traveling for 13.8 billion years. Right now, some of the static on an old analog television set is made of that exact light. You have touched the beginning of time and never known it. But a background glow from the birth of the universe is passive. It is old light with nowhere left to go. The next signal on this list is not old. It arrived within the last decade, and it is still being debated. In 2020, the Breakthrough Listen project detected a narrow radio signal, drifting in exactly the way you would expect if it came from a planet orbiting another star, and the direction it came from was Proxima Centauri, the closest star system to our own, just 4.2 light-years away. Signal 6 on this countdown was nicknamed BLC-1, and for months, a small group of scientists quietly investigated it before going public, because a signal drifting from our nearest stellar neighbor is not something you announce carelessly. The signal was eventually attributed to interference from human technology on Earth. Eventually attributed, not proven. And that distinction matters more than most viewers realize, because if a false alarm from our closest neighboring star can cause that much scientific hesitation, imagine what happens when the signal comes from somewhere we cannot explain away so easily. Signal 7 on this list does not come from a radio dish at all. It comes from light itself, dimming in ways that should not be possible. A star catalogued as KIC 8462852, nicknamed Tabby's star, dims by as much as 22% at irregular, unpredictable intervals, far more than any planet passing in front of it could cause. A planet the size of Jupiter blocks about 1% of a star's light. Whatever orbits this star blocks, over 20 times that. Astronomers have proposed swarms of comet fragments, dust clouds, or debris from a shattered moon. One early hypothesis, now largely dismissed but never fully forgotten, suggested a megastructure built to harvest the star's own energy. If you have made it this far, into the strangest signals ever recorded, this is a good moment to like this video and subscribe, because the next entries on this list stop being about stars and start being about the fabric of space itself. Because light and radio waves are not the only signals space can send us. In September of 2015, detectors in the United States picked up a distortion in space-time itself, a ripple lasting a fraction of a second, caused by two black holes colliding over 1 billion light-years away. Signal 8 on this countdown is a gravitational wave, and it does not travel through space the way light does. It stretches and compresses space itself as it passes, meaning that when that wave crossed Earth, every object on the planet, including your own body, shrank and stretched by a distance smaller than the width of a proton. You felt nothing, but you moved anyway. If space itself can carry a signal, then the natural question becomes what happens at the center of the galaxy, where gravity is strongest and light itself struggles to escape. At the heart of the Milky Way sits a supermassive black hole named Sagittarius A star, and in 2022, astronomers released the first direct image of it, a glowing ring of superheated gas surrounding total darkness. Signal 9 on this list is the radio and X-ray flaring that erupts from that region almost daily, flashes of energy dozens of times brighter than its normal glow, appearing and vanishing within minutes. Sagittarius A star itself is small compared to other black holes, about the size of a tennis ball if the entire solar system were shrunk to fit inside the orbit of the moon, and yet it is 4 million times the mass of our sun. Every flare from that region is a signal from the edge of an object that swallows light itself. And somewhere in the dark spaces beyond it, there could be signals we are not equipped to detect at all. Which brings this list to the entries we cannot confirm exist because our instruments were never built to find them. Signal 10 on this countdown is not one detection, but a category. The search for technosignatures, deliberate signs of engineering picked out from natural background noise, things like laser pulses timed with mathematical precision, or atmospheric chemicals that should not exist without industry producing them. Multiple candidate atmospheric signatures have been proposed on exoplanets in recent years, only to be re-examined and downgraded once better data arrived. Every single one of them has followed the same pattern. Initial excitement, global headlines, and then quiet retraction. No confirmed technosignature has ever survived scrutiny. Not one. And that fact alone should unsettle you more than a false positive ever could, because it means every signal we have found that looked artificial turned out to be natural, and every signal that might be truly artificial may already be sitting unnoticed in data we have not finished analyzing. Which leaves the final entry on this list, and it is not a signal at all. Signal 11, the last one on this countdown, is silence itself, the complete absence of any confirmed signal from another civilization anywhere in the observable universe, despite over 60 years of dedicated searching across billions of star systems. This is known as the Fermi paradox, named for physicist Enrico Fermi, who asked a deceptively simple question: if the universe is old enough and vast enough to have produced countless civilizations, then where is everybody? No answer, no confirmed contact, no verified transmission from beyond our solar system, ever. That silence has produced more competing theories than any actual signal on this list, ranging from civilizations destroying themselves before reaching the stars, to life being far rarer than we assume, to something else entirely, something we may not have the framework to imagine yet. Every signal on this list, from a 72-second burst in 1977 to the silence stretching across the entire observable universe, points toward the same unresolved question. We are listening. We have been listening for decades. And so far, the universe has only answered us in static, pulses, and afterglow. If this kind of quiet, patient search into the dark keeps you up at night in the best way, subscribe and check the playlist below, because there are entire galaxies of signals we have not decoded yet, and the search does not end here.